Hello everybody, it's been a while. We've not been doing too many videos, obviously, as you've noticed. It's quite busy and these videos are a little bit time consuming, but we've got a vehicle in today that we've not seen before, never had one in, so we thought we'd do a video on this because the customers had asked us to do some modifications. So let's go and have a look. Lovely cold December day, right for these sort of four-wheel drives, and that's what it is. It's a four-wheel drive that we're having a look at, so let's spin the camera around, you can have a see. Here we go, an Ineos Grenadier, first one we've seen in the workshop. We have seen a prop shaft before off them, but this is the first time we've had a vehicle in the workshop, and I've got to admit I quite like this, and I don't really like Land Rover Defenders or G-Wagons as such. Defenders are annoying. Why would you buy a Defender when you can get something comfortable, better and that works? But hey ho. But yeah, this is a nice looking vehicle. So the customer has actually modified the vehicle slightly. You can see it's sat up. He's had a lift put on it. So we'll just have a quick look underneath. There we go. So he's had a lift put on this and he's spent quite a lot of money on it, doing all sorts of shockers and such. New brakes and all sorts of things. Looks quite good. And his problem is this prop shaft. So this has got a CV prop shaft on it. Most four-wheel drives, modern four-wheel drives, SUVs do tend to use CV joints. A bit more heavy-duty vehicles like the Defender and a few others will use universal joints, but this is using CV. Now the problem that he's got is this prop shaft is sitting at a huge angle, and if we can see up there, if we can zoom in, his problem is that you see all the grease that's around there. The boot on the inside is ripped off. The boot's ripped because it's running at such a steep angle, and it's the same with the back shaft as well. The back shaft isn't quite as steep, but it's certainly running at a steep angle. So what we're going to do is we're going to change these prop shafts, the CV joint style prop shafts, to a universal joint style, and to do that we have to change this whole system to be able to accept a universal joint rather than a CV joint. So we'll show you how we do that and what we do to do that. The prop shaft's off now. We've got it here on the bench, and it's quite a big, unique little prop shaft. We'll give you a sight on it. So here it is. This is the Ineos original prop shaft, CV joint, an 8-bolt CV joint running to a welded sliding section, so the male and female sliding section underneath here, onto another, welded onto another male stub, welded onto another CV joint adapter, coming back down into another 8-bolt CV. Now, there's an awful lot going on there. This shaft, manufactured by Dana Spicer, looks like they've, probably because the Ineos is so bespoke, I don't think they've had all the castings made properly yet for everything on it, so they've made something out of what they have kind of available. Good engineering, but it is kind of, you wouldn't usually, I think on a finished product, you wouldn't usually have all these welds on it, sort of thing. You'd probably have that component made complete with a sliding section on, so you wouldn't have these two welds. That would all be one cast component, but that's what we've got at the moment, so that's what they're dealing with. So the idea is to change this CV joint to fit a universal joint instead. So the universal joint will offer more angle. When it bends, it won't foul against, what's happening is it's fouling against this casting like this. So it's ripping through the rubbers and ripping inside. Here's a rubber boot. It's ripping those rubber boots, especially on the other shaft that's still on the vehicle. The boys are just taking it off at the moment. So we can get these blank castings, so we can do what we want with these. So the idea is to machine it to this diameter and put the correct PCD and bolts in. So we already knew about this job coming in. It came in 2 weeks ago to us. So we've been trying to find the castings for it anyway. We managed to get hold of these, and we've got some final machining to do on these. Well, so this is the casting that we're going to use. So instead of having a universal a CV joint there, it's going to be a universal joint bolted direct onto the diff behind this, because this has obviously got a sliding section. I just pin it on the floor. That all right? It's all right, no problem. Thank you very much. Ethan just behind me. So this is going to go onto this sliding section here, and then we'll have a nice length of tube, and it will go onto this at this end. So we'll only have 2 welds, 1 weld here, compared to 1, 2, 3, 4 welds. It means we can get it straighter as well. Although I'm not saying this isn't straight, this will be perfectly straight. Dana do a good job, they're a good company. The idea is that we can make it a little bit more heavy duty. You might have seen these Ineos on a few other YouTube videos. If you search Ineos Grenadiers, you'll see these sorts of things. People have put double cardans on them and all sorts, but we're going to stick with single because double cardans don't always work. Sometimes they cause a bit of vibration and resonance at high speed. So the idea is to make this prop shaft here using this sliding section. I'll just give you a view of this sliding section, how good a quality it is. So this sliding section is an involute spline. See if we can get it apart nice and tight. Oh, too tight, put it in the vise. There we go. So this is an involute spline. Really good quality, nice tight spline, long movement. So the whole sliding section, the whole spline length, it's got about 110 mil of slip, so any kind of large articulation sort of movement will handle it quite well. And if you just look at the difference in size between this one and this one is slightly bigger. So it's a slightly bigger spline than what's on this one, a little bit more heavy duty. We'll use probably the same sort of diameter tube, around about the 60 mil diameter tube for this. And let's go through and get it produced. We'll just go and have a check that our final machining on these flanges is good to fit the vehicle, and then we'll put the prop shafts into production for this guy. So we're back underneath here now. The prop shafts are off, as you can see behind me. That's one of the flange fittings there, and the other flange fitting up here. So I'll just spin you around so we can have a look at these flanges themselves. So this is the front diff, this is the flange here. Probably need to clean this off a little bit. You can see a little bit of rust marks where it's going to be tight on the inside. But the idea is that this flange is going to sit inside there. That's going to be nice and tight. Sit inside there and bolt onto that direct inside there. So it's a direct replacement. For this, we've had to do a little bit of machining on the outside to get it to fit. But it is still a little bit tight, but it's supposed to be tight. I don't want to put it all the way in because we want it to be a slight interference fit. There we go. So that'll go in. There's 4 of those flanges that we've made, and they'll fit transfer box, rear diff, and rear transfer box. So they'll fit in all. It's the same flange that fits in all 4 of these, but all nice and tight. This is a German British engineered vehicle, manufactured in somewhere in Europe. I think it might be Spain, I'm not too sure. I didn't actually have a look at it, but it's Mr. Ineos, Manchester United. This is his vehicle for the replacement of the Defender, because obviously we've lost the Defender now, or the Defender as the original Defender was as an agricultural vehicle. Now it's moved to more of an SUV sort of vehicle. Still be used off-road, the new Defender, but it's more of an SUV type of vehicle. I don't think you'll see your farmers using it as much as what they would the old vehicle, but I think this is the idea behind this. Is this could be the sort of vehicle that you use, although there is a lot going on underneath here. There's a lot of stuff going on which a lot of agricultural people possibly don't like. Can it be fixed with a spanner? Probably not. A lot of electronics, lots of sensors. Lovely vehicle though. I do actually quite like it. So right, let's get back into the workshop and we'll see these prop shafts being made. Here we go. Shafts being put together using premium spicer joints. Dana spicer, the same as what the original was made. So that's the front end, and the back end is over here. Once we've got those done, they will be pressed together with the tube. This is brilliant about Dana. You get 101 different coloured circlips, so you know you've got to put the exact right ones in depending on the tolerance that you've got and the castings that you're putting them in. So one circlip, 4 circlips, doesn't always fit all. Sometimes you have to play with the different colour of circuits. So you can see we've got three different colours here, and it all depends on the casting that they're going into and the tolerance that you want. But usually with the spicer ones, you get a nice bag of all different thicknesses of circlips. Right, so it's tube next. We'll leave the guys to it to get that sorted for the next hour or so. This is the other shaft in here. Exactly the same as what the first one was, just a different size. So the only difference between the two of them was the length. This is it, sorry. Oh. I'll show you the problem. The problem that we've had is this. So this is, look at that. Completely ruined the rubber on the inside because it's been working on an angle like that. It's just ripped it all. So that CV joint has failed. Customer's lucky it's possibly not come off, but that's the whole point of bringing it into us so that we can sort this for him. So yeah, that's the problem that they're getting on these Ineos Grenadier. It's actually Christmas time now. We're a little bit quieter in here. So we've got a nice Christmas tree. There's our little Christmas tree in the back. There we go. There's the Grinch. Right, so we'll leave them to do that, and we'll crack on with some other stuff. Here we go. This is the first shaft, all welded up and sorted, ready for checking, straightening, and balancing. Morning, back on the next day on this Ineos build, and the prop shafts are now painted. Let's have a look at the prop shafts before they get installed. There we go, all nicely painted. That's the short one. So the long one's somewhere knocking about the workshop, or just so we're going to go and install them then. We just have to modify some bolts to fix. Obviously the original bolts quite long to go through there and into the CV face. These are slightly shallower now that we've machined the edges, quite a bit thinner. So we'll just have to modify some bolts or make some bolts to fit those. And those are the new universal joint style shafts to suit the Ineos. We'll go and fit them and we'll show them to you once they are fitted. Well, the prop shaft for the Ineos is now on, so we'll just go, oh, grey day, winter day, have a look at it. This is the Ineos again for you. There it is, lovely vehicle. Really nice vehicle. I like this a lot. So let's have a look underneath and look at the new prop shafts that we've got. So here we go. This is the new style universal joint, or old style compared to this vehicle. Obviously this vehicle had the CV joint on it. Now we've got the universal joint on it running up to the transfer box. So this prop shaft, we've actually made this perfectly in line. So the yokes are perfectly in line with each other. The front prop shaft, because it runs on a little bit more of an angle, we thought we would phase it. So the phasing means that this face here is 35 degrees off to the face at the front. So that means that it doesn't reach peak angle at the same time. The front and the rear don't reach peak angle at the same time. So it doesn't cause a big oval run out. Like universal joints don't run in constant velocity, they're running in an elliptical pattern. So they don't reach the peak angle at the same time. They'll reach peak angles slightly off, which allows us a little bit less resonance. But there we go, that's that fastened up all at that end and fastened down here. So now off it goes to the customer. We'll see what the customer thinks. He'd seen this sort of design on several American websites. We don't see many of these in the UK, so we might see another couple again. But this is maybe a heavy duty way of adapting this vehicle. Same sort of thing on Land Rovers really, they do the same. They put big heavy duty universal joints and double joints and all sorts of things on them. So this is the same sort of theory, it's just that this is attaching to a CV joint where we've had to machine these flanges or get the castings in and modify the castings so that it fits inside this CV block. Anyway, thank you very much for watching this video on the Ineos Grenadier. If you've got any questions, please let us know. Or if you anything whatsoever, give us a call. If you'd like a set of these, 01257 791 681. It is Christmas time, so Merry Christmas everybody. That's why I've got the old hat on, and I don't have my glasses on because today I've been playing Father Christmas at a school. My yearly treat to the local schools. They get to see me dressed as Father Christmas. So anyway, have a good Christmas, and we'll speak to you next year. Bye bye.